Hi there, welcome to Masopa sextraclass. So today we'll be looking at function, but before we discuss, let's quickly remind ourselves what we were doing. More grade 11. We have a straight line. The formula of the straight line is y equals to mx plus c, right? And the most important thing we have m, right? And our m, it represents our gradient. It represents our gradient. And to get the gradient, you're gonna see m is equals to y2 minus y1 over x2 minus x1. Right. And there's important thing you must know about c. Our c is our y-intercept, right? The y-intercept. So once you say y-intercept, you're basically meaning that where x is equals to 0, meaning that where x is 0, you're gonna have a defined y value. Normally, a y value more x equals to 0. And also, guys, when you say a y-intercept, or rather when you're looking for the intercept of the graphs, whether parabola, hyperbola, or whether you're drawing a graph, you must always at the end indicate our gradient is very important because it's gonna tell us in which shape will our straight line look like, right? So if our gradient is greater than 0, meaning that our gradient will be positive, then our shape will look like this, right? Then if our gradient is less than 0, then our shape will look like this, right? So it's all things that you must know in straight line. Moving on to parabola. Graph, right? So basically, parabola, we are talking about this kind of graph that look like this. Okay. Now, parabola, it has three formulas, right? So the first one, we call it a turning point, whereby your y is equals to a over x minus p squared plus q, right? So I said this one is for turning point, right? So remember, p, it will represent, rather is our x value of the turning point. Then q also, q is our y value of the turning point, right? Meaning that if we have x value there, let's say here at the turning point I have 3 as x value and 4. Basically you're gonna see y is equals to a, then x minus, because at the turning point we have 3 minus 3 squared plus your 4 as your y value, right? And then what you're gonna do, you're gonna break this bracket so that you're gonna solve and then solve it. Then when you solve it, you wanna have the standard form where y is equals to ax squared plus bx plus c, right? So this one is in the form of standard form. right? And the most important part about the standard form is that our C is still our y-intercept. Why? Because if you let x is equals to 0, it will be undefined here, because when you see 0 times any number, you will get 0. So it will all be defined and you will left with C. Then for you can able to get your y-intercept. With the standard form, you can also find the x value of the turning point. How? Also, this, okay, let me see, x is equals to minus b over 2a, right? So with this equation, you can normally get the x value of the turning point and also the axis of symmetry. Right, and then you have the last one, which is in a x-intercept form, right? Whereby you see y is equals to a over x minus r1, then x over r2. Basically, r1 and r2, it will be your let's see, your x values. This one is the x-intercept, whereby we have x-intercept. Obviously, in a parabola, you will have two x-intercept, whether here or there. Then you're gonna plug you over there and you're gonna solve until you get it from standard form. Right, also in parabola, remember that our formulas, they have a's, right? So that a is much important because it's gonna tell us the shape of our graph. So if a is greater than 0, our graph will be concave up, will be concave up. It will look like this. So if a is greater than 0 or is positive, our graph will be, it will smile. Our graph will do what? It will smile. Then if a is greater than 0, meaning that our graph will be concave down and our graph will be sad, and our graph will be set. And if let's quickly look at the domain, and the range. So basically, a domain, our x is element of a real number. At a range, if our a is greater than 0, our y will be defined from remember our q, our x value of the turning point. So you're going to start from there to be defined to the infinity. So you what? Positive infinity, because it will start here and goes, because if let's say right, let's say we have our parabola. Let's say our y there, rather our y value of the turning point, which is 2, let's say is we just naming numbers. Let's say is let's say it's 0, right? So when you write a range, you're gonna say y is an element from 0 to positive infinity, because this graph, it goes down. So not down, it goes up, and it will be defined as it goes by. Alright. Then if a is less than 0, then your y is element of negative infinity. Okay, negative infinity to q, meaning, let me write it here, because if a is less than 0, that means our graph will be set. And then let's see our y value, or rather our q, which is the y value of the turning point. Let's say is negative 3, right? Then when you say the range, your range will be y is element of negative infinity to negative 3. Okay. Then let's quickly look, or rather remind ourselves about hyperbola. So at hyperbola, so normal hyperbola is like a butterfly, meaning that it will a butterfly. I normally call it a butterfly graph because it's a graph that look like this, and then you're gonna have a beautiful butterfly there, right? Right. So hyperbola, we're talking about a graph that has two asymptotes, right? Where is the general formula equals to y equals to a over x minus b plus q. Our q is our horizontal asymptote, meaning that y is equals to q. Then p, be careful with p, because p is the sign change. So p is our vertical asymptote, but vertical asymptote. So meaning that our x vertical asymptote will be x equals to p, right? So be careful. If let's say in our, or rather if you are given a formula whereby your p is positive and they ask you what is the vertical asymptote, you're gonna say x is equals to, you take the minus sign, it's equals to p. I will explain it when you're doing questions if you don't understand. Then if we say asymptote x is equals to p, if we have a negative vertical asymptote, and then this x is equals to p is the one that you're gonna draw, or rather is the one that you at the graph. Gonna get what is your asymptote that you're gonna draw at the graph. Mo graph. Asymptote ya gago e dira mo graph. If we have a positive negative p mo your general formula, then that means that mo graph I must see the difference to it must be positive. Then if mo graph ya gago mo general formula ya gago, yeah, we have positive p, positive vertical asymptote, then in your graph it must be negative, so vice versa. Be careful of that. And also hyperbola, when you are looking for the axis of symmetry, is rather than we have a positive gradient, or we have a positive gradient, or negative gradient, and a positive gradient. For the positive gradient, your y will equals to x minus p plus q. Then for the negative gradient, y is equals to negative x plus minus p over plus q. Right, let me show you. Alright, so let's say they're looking for the positive gradient. Basically, you're gonna take your your axis of symmetry where x minus p plus q, you can see that. So this one, it will represent the positive gradient. Then for the negative gradient, you normally gonna put negative in front of your then you're gonna look at the bracket where x is x minus p. Alright, now let's look at our last which is exponential. Bless me. Exponential graph. So our exponential graph is equal to y a times b x plus p plus q. And our exponential graph, it has only one asymptote. So exponential, it has only horizontal asymptotes. Horizontal asymptote. It is what? Only horizontal asymptote, whereas y is equal to q. That is your asymptote. And also a is very important, because if a is greater than 0, or rather is positive, our graph will be our graph will be above, or rather our graph will lie above your q. Rather, if you see your q, you know what I'm talking about, your asymptote. Then if your a is less than 0, it will lie below your asymptote. Let's say our a is greater than, for an example, let's say a is greater than 0, right? And this is our asymptote. Then we have a Cartesian plane. Then you say the a is positive, meaning that, let me make it so very nice. Okay, if a is greater than 0 or is positive, I say that it's going to lie above asymptote. So and also the shape will be defined by the b, whether it will move like this, or let me change a color, or it will move like this, as long as a is greater than 0. Then back to black. If a is less than 0, or rather a is negative, so if our a is less than 0, it is going to lie below our asymptote. So it's rather going to move like this, or like that.